Alrighty. Good morning, everybody, and welcome back to Calc 1. Plan for today. We're gonna start working on our first learning standard of the semester, Standard 1, which is going to be focusing on average rates of change of a function. I don't normally have any office hours on Fridays. I'll probably be around from like 11 to 11:30 today if you want to stop by, but that's not always going to be the case. My next official office hours will be on Monday at 11 and at 1. And as far as homework goes, I posted a second web work assignment. So you still have your web work assignment due Monday, homework 1. That's sort of the introduction to web work, not really much actual math to do. And I posted the actual first mathy assignment, homework 2, which will be due on Wednesday. So, question. When I say that an online homework assignment is due Monday, for instance, what does that mean?
11:59 Monday?
11:59 p.m. So, whenever I say an assignment's due on Monday, it's not due by class time necessarily or anything like that. I've always set it up so that it's due at the very end of the day. So, something to keep in mind. And as a reminder, homework assignments are optional. I encourage you to work through them as kind of a way of practicing for quizzes and exams. And once the homework deadline closes, you can no longer submit your answers, but you can still go in and actually see WebWorks' own solutions to each problem. And if you disagree with something that WebWorks has, check your answer, check it again, check it a third time, and talk to your classmates or ask me. And you can earn up to 2 bonus masteries, as I mentioned last time, at the end of the semester, depending on your overall homework score. So, with that in mind, any questions or comments before we get started for today? Why is it a bad idea to try and teach a horse analytic geometry? Because you shouldn't put Descartes before the horse. Okay, and with that, we'll start our first theme. One other thing I should mention. Pre-tests. So, how many of you felt intimidated by the pre-test you took on Wednesday? So, I got the scores back. There's 1 C, and everybody else failed, based on the automatic scoring system I got, which is good, which is what I want. I want you all to start off as failures so I can mold you into creatures of my own creation. But really what that means, I have a couple things I just want to say about that. 3 things. First of all, as I said last time, your scores do not matter in any way for your grade in this class. Second, for exams and quizzes in general, going forward, you'll have more time per question than what I gave you for that thing. So if you felt like that was super rushed, it won't always be that way, hopefully. And third of all, the content that was on that exam for the most part was Calc 1 questions. So this stuff, if you feel like you didn't understand a lot of the questions that were on the exam, that was intentional. You're probably in the right class then, because we're going to be talking about how to solve each and every one of those problems over the course of this semester. So don't feel bad if you felt like that exam kicked your butt, because I can assure you it was in him too. Let's go ahead and pass all these out. 4, 5, 6, 1, 2, 5. I can already see there's going to be a problem. 1, 2, 3. Okay. Take a look at the front page for a second and ooh and ah at its majesty. I didn't hear enough oohing and ahhing. Okay, so I printed these out a couple days ago, and you may have noticed we have some new additions to the class since then. So, Dr. Gerstle packets. Each time we start a new standard in this class, I'm going to be passing out a new packet. All packets will be posted on Canvas, so if you kind of forget to bring yours to class or you lose it, you can go download a new copy. And these are something that I like to use as sort of like a skeleton for taking notes for the class. Which basically means I might include like questions on here and leave you a bunch of blank space to write down answers. I use these as a way to help me organize my own notes for the class. You are welcome to use them. You are also welcome to not use them to take notes and to use your own notebook or whatever system you prefer. They're there as an option for you. And generally, you will know that we're done with the standard because we've reached the end of the packet. There. So, before we get started on standard 1, I want to talk a little bit about the 2 things we're going to be doing this semester. First of all, we are going to be talking about rates of change. How fast are things changing over time? So, for instance, in this first standard, when we look at an average rate of change of a function, we're going to be talking about a car going down the road and trying to see what can we approximate the car's velocity or speed to be as it's going down the road. And we'll be doing that for the first half of the semester, answering questions about rates of change and velocity. Second half of the semester, we'll be mixing it up and talking about areas. Specifically, you all may know how to find the area of a square. I hope you do. Or the area of a triangle. Or the area of a circle. But we will be talking about how do you find the area, things like that. And it's going to turn out that we're going to have a 6th theorem at the end of the semester, fundamental theorem of calculus, that's going to tie those 2 topics together, finding areas versus computing rates of change. All right, so that's my spiel. So here's the scoop. We're assuming we're going to have a car that is traveling down the highway that's traveling in a straight line. So assume we have a 1-dimensional highway that the car is traveling down. After 0 hours, the car is at home. So it's because it hasn't started going yet. So its distance from home is 0 miles. After 1 hour, it's 60 miles from home. After 2 hours, it's 100 miles from home. All the way up to 7 hours, where at some point, maybe around 5 hours, the cars realize, oh shoot, we forgot something, we need to start going back. What I would like for you all to do is to reintroduce yourself to your neighbors, so maybe like 1 or 2 of the people sitting around you, and with your neighbors, I would like for you all to work through the first 3 pages of this packet together. So go ahead, take a few minutes, work on the first 3 pages, and before you get started, everyone's attention for a second. I'm going to be walking around the room. Flag me down if you and your group have any questions, or raise your hand, say Dr. Gerstle, say, yo, Dr. G, get over here, however you prefer. Okay, that's fine.
No, not just this job.
Oh wait, no, it did turn around. It did turn around.
Somehow them all out, see if it's somehow like saving something that's not supposed to be. It's not remembering whatever bug in the programming.
Oh, yes, that's right.
Your batteries are low. I think. Try changing out the batteries to new ones and see if maybe that fixes it. Okay. Yeah, so you probably go to the campus bookstore. I bet they'll have some batteries.
-30 over.
Not for today. That being said, nothing in this packet I think really necessitates the use of the calculator. Mostly just plugging into very simple functions. But yeah, let me know if you can get this resolved by As a reminder, go ahead and try out the first 3 pages of the packet. Again, after a few minutes, we'll come back and discuss what you found as a class.
Yeah, because the 6 times 4.
Yeah, I bet that is yeah. Because if it's calculating the whole lot, but I mean it's the same.
Let's say that it wasn't good.
Velocity is 0.
I would say it didn't go. It didn't.
Well, it's hard to do.
It went somewhere, but
Yeah, it did, but whatever.
it began and
But brain thinks nothing else is safe.
Negative velocity.
So the card that we stay on the same spot.
Hey, Bruce. Cut these. For you, we're going to have to do some proofs this semester. I'll try and traumatize you a little bit less than your previous.
when I was trying to gain or almost like on the ground, like it didn't get any kind of update, because,
Let's give it about another minute and then we'll come back together.
I don't know, so I got myself 0. Okay, yeah, because you need that time there. Oh, sorry. Oh yeah, you need to have the distance over the. Okay. Oh yeah. For the velocity. Oh yeah.
it's exactly so exactly.
It means that it turns
Really?
I don't like.
And it's a look of being impressed.
Got it.
Yeah.
Good news.
Okay.
Alrighty, let's come back together. So in general, I'll usually try in most classes have at least some portion of the class be like small group work like this, where I give you some problems or a problem and ask you to kind of think about it or work together on it. I won't always necessarily do that. Depends on kind of how appropriate it is for whatever topic we're looking at. But I like giving you a chance to think about some ideas together on your own without me just having to explain everything. That's not. I don't know. That doesn't sound as fun for me or for you. So what can we say about f of 3? If f of t is the, oops, I forgot to actually write that down lower. If f of t is the function that says the car's distance from home after t hours, then what would f of 3 be in this case?
150.
150. Well, distance from home is if t equals 3, so this is sort of the t row of our table, then we can go to the f of t row and see that if t is 3, looks like f of t, so f of 3 should be equal to 150. Meaning that the car's distance from home after 3 hours is going to be 150. 150 what? 150 yards, 150 miles, 150 light years.
Miles.
Is this car actually the magic school bus and going out into space on this? Sorry, that might be before your time. Yeah, it's going to be 150 miles. To basically say that after 3 hours, the car is 150 miles from the home. How about f of 7? Similarly, if we go here at 7 down to 120, we get 120 miles, telling us the car's distance from home after 7 hours have passed. All right, time for some crazy arithmetic. What's f of 7 minus f of 3?
Negative 30.
Aha! Negative 30. And since f of 7 and f of 3 are both going to be measured in miles, their difference, I think, should also be measured in miles. That's going to be 120 minus 150, which will give us our negative 30. So what does that number mean? Negative 30 miles. How can you have negative miles? Should distance be positive? I'm sorry, he said?
The car turned around so it got closer to home.
Ah, the car got closer to home. So in other words, this negative 30 miles doesn't say the car traveled backwards in time necessarily or anything like that. But what this negative 30 means is that the car's net distance from home decreased by 30 miles from 7 to 3 hours. I.e., after 7 hours, the car is 30 miles closer to home than it was 3 hours after the car started driving. And so this sort of change in position from one point in time to another, in this case f of 7 minus f of 3, this distance from home after second time point, 7, minus distance from home after first time point is just telling us our net distance traveled. Now, you might say, but Dr. Gerstle, the car didn't just go 30 miles during that time frame. Looked like it went 40 miles and then another 10 and then another 10 backwards and then another 70 backwards. And if I take 40 plus 10 plus 10 plus 70, something tells me that's going to add up to a lot more than 30. Whenever you talk about net distance traveled, you're generally going to you don't really care about what happens in the middle between your two time points, between say 3 and 7 hours. Instead, net distance only cares about what's the overall change between start point and end point. And so the fact that the car, during this 4-hour time frame, the car moved forward for a while and then went back more than it had gone forward during that time frame. The negative 30 doesn't care about the fact that it went forward and then back. The negative 30 is just saying at time t equals 7, it's 30 miles closer than at time t equals 7. Any questions, comments, or concerns? Alright, so in that case, I'm going to look at average velocity of our car during this time frame, our 4-hour time frame. Or in general, our formula for computing average velocity is going to be net distance traveled over the time that's elapsed during the course of whatever time period we're looking at. What's that going to be in this case? Negative 7.5 miles per hour. Good golly, how did you get that?
But net distance travel is negative 30 over 4.
Okay, so you took the negative 30 we got from the bottom of the previous page, and you divided by 4 hours, which I assume you took from taking the 7 minus 3?
Yeah.
Yeah, so we could say 7 minus 3 hours is going to give us, what, negative 30 divided by 4 miles per hour. And then, of course, for those of you who are twitching because I just wrote a fraction up on the board that wasn't simplified, we can divide our top and bottom by 2. You get negative 15 halves miles per hour. And for those of you who are still twitching because you don't like improper fractions, we could say that negative 15 halves is the same as negative 7.5. So what do y'all think? Anybody prefer one of these answers to the other? See some head shaking.
The bottom one,
You like the bottom one?
preferably, yeah.
Why is that?
It's just, I guess it's simpler, but I guess in the top one, if you're dealing with fractions, it's more preferable as well. Or in the middle one, I guess. So I guess it depends on the situation, but if we're talking about right now, the bottom one.
Talking about right now, this feels like something that's maybe a little bit more usable in terms of information, whereas if I told you negative 34ths, you'd have to pause and think, wait, what approximately is that? I don't have a good sense of what that means as opposed to negative 7.5 or negative 7.5, let's say.
Right.
I'm gonna be honest with you all. I have a confession to make. I'm a theoretical mathematician at heart, which means I'm lazy and don't care about how useful my answers are. I just want to get an answer. So I'll be honest. If you had given this question to me on a quiz or exam, I may have very well stopped here. My opinion, though, all of these are equally correct because they all represent the exact same number. The negative 34ths, and negative 15/2, negative 7.5, negative 7.5, they're all exactly the same to me. And so, if you had answered any of these, if this was a question on, say, a quiz, it would have been kind of discorrect. If you want, you can simplify your fractions, you can write it in decimal form. I'm okay with that either way. Make sure you have your units though. Also, by the way, if this was a web work question, web work would have accepted any of these as answers as well. So for web work, you don't necessarily need to put in like your answer in decimal form. If you just had typed in negative 30/4, it would have given it to you. What does this number mean in context though? When we say that the average velocity from time t=3 to t=7 hours is negative 7.5 miles per hour, what's that telling us? How can velocity be considered to be negative here?
On average, it just like moved 7.5 miles closer to home in between each hour.
Ooh, I like the way you put that. On average, over this time frame from 3 to 7 hours, the car is moving 7.5 miles closer to home each hour. Why did you say closer to home instead of away from home?
Because typically it's like, or while the distance, the farther away it is. Sorry, I'm trying to make a describe it. So the bigger the number. Oh wait, no. Sorry.
You're doing fine.
Yeah, okay. So if it was positive 7.5, then that means it was 7.5 miles farther away from home. But because it's negative, it signifies that the acceleration is negative, so it's 7.5 miles closer.
Be careful around throwing the A word around here. Acceleration. Not because I consider it a bad word, but because you have to be careful how we're going to use that for reasons we'll be talking about later. But yeah, I like the way you described that. We know it's going to be getting closer to home because of this negative sign out. Because of that negative sign out there. The fact that our average velocity is negative means on average over that time frame the car is moving closer to home than it is moving away from home. The net distance traveled, in other words, is negative as opposed to being positive, which would imply further movement away. So in general, whenever we talk about velocity in this class, you always have to think about velocity having a sign of being positive or negative, where positive usually means it's moving away from its starting point, and negative usually means it's moving back towards it. If f of t is measuring distance from starting point, let's say. Any questions, comments, or concerns thus far? Groovy. Now let's do the same thing, but instead of from 3 to 7 hours, we're going to do it from 4 to 6 hours. So I think we can use the same general formula to help us compute average velocity over this time frame. We can still use net distance traveled from 4 to 6 hours divided by the time elapsed. Whereas in this case, I think that our time elapsed is going to be 2 hours. So put net distance over time elapsed. We're going to have 4 minus 2 is, or 6 minus 4 is 2 hours, which is also equal to 4 minus 2, but that's besides the point. What was the car's net distance traveled from 4 hours to 6 hours according to our table?
0.
0? 0 what?
0 miles.
Now technically here you could also say 0 feet and 0 light years because 0 and any unit of measure, any distance measurement unit would be the same. But yeah, it's going to be at time 6, it's 190 miles away. At time 4, it's 190 miles away from home. So that's going to give us 0 miles over 2 hours, which is going to give us 0 miles per hour. For miles per hour, by the way, if you want to use MPH like it often gets abbreviated to, you're welcome to, or you could write it out like this, like miles divided by hour. They mean the same thing. Yeah. And yes, technically, if you wanted to be cheeky, you could say it's something like, oh, it's 0.7 miles per hour. You know, just in case you felt like being a little bit sassy with your quizzes or your exams or your homework. It means the same thing. To a theoretical mathematician like me, they're equally good, and I'm all in favor of cheekiness. What does that mean, though? We have our car's average velocity from 4 to 6 hours is 0 miles per hour. Does that mean the car didn't move at all during that time frame?
It means the velocity stayed the same.
Velocity stayed the same, so it didn't change at all from 4 to 6 hours?
And like overall, the average of it stayed the same.
On average, it stayed the same. Gotta be a little bit careful. I don't think it's necessarily saying the velocity on average stayed the same. Well, technically it did.
The distance from home remained the same.
Yeah, I would say on average the car is moving 0 miles every hour closer to / away from home over that time frame.
Whatever distance it moved in the positive direction, it moved an equal distance in the negative direction.
Yeah, the distance away. Yeah, another way to say that would be to say that all of the distance away from home during that time frame, from 4 to about 5 hours, was canceled out by distance moving back towards home during the same time frame. So we can say lots of different ways of saying the same thing, which is that on average, the car moved 0 miles towards / away from home over this time period. We gotta say on average, because if we left that off and just say, oh, the car is moving 0 miles over this time period, that I would consider to be a false statement. Because obviously, it's not true that the car is not moving at all from 4 to 6 hours. Otherwise, at 5 hours, it would still have to be at 190 miles away from home. But the fact of the matter is, any positive velocity was sort of canceled out in a sense by negative velocity, meaning the net distance traveled turned out to be 0, and so our average velocity ended up being 0 divided by that 2 hours, and so we had an average velocity of 0 miles per hour over that time frame. Questions, comments, concerns? All right, here comes the tricky one. So y'all did a good job, I think, of finding average velocity from 3 to 7 hours and from 4 to 6 hours. But what if I asked you to find the average velocity from T0 hours to T1 hours and ask you to give me a general formula where we can plug in terms of T1 and T0, that we can plug in any numbers we want for T1 and T0 into that table?
It would be f of t naught minus, or f of t1 minus f of t naught over t1 minus t naught.
F of T1 minus F of T0 over T1 minus T0, like that?
Yeah.
Ooh, how did you come up with such a thing?
Well, when you go back to what we were doing, we were always putting the inputs, the inputs were on the bottom and the outputs were on the top of the function. So instead of having it be real numbers, it was just variables for which they represent.
Yeah, so in other it's T for time elapsed in this particular case. But yeah, the T1 minus T0 will give us our time elapsed. The F of T1 minus F of T0, as we kind of said on the second page, is going to give us our net distance traveled. I tried to write net distance, it came out with net somehow. Shout out to Game of Thrones. And so a general formula for net distance traveled over time elapsed would be F of T1 minus F of T0 over T1 minus T0. Where now that we have a general formula for T0 and T1, we should be able to just, if I were to ask you, hey, from 1 hour to 5 hours, what was the average velocity? You could just plug T0 equals 1, T1 equals 5, and boop, bop, bit, blah. And just simplify that answer and you don't have to really think about it. Having a general formula can oftentimes be nice because it allows you to just kind of plug and chug if you were to want to compute average velocity over a bunch of different time frames, rather than just having a specific time frame in mind. I like it. Yes?
Would it matter if you swap the T0 with T1?
Ooh, good question. So if we had said, for instance, f of T0 minus f of T1 over T0 minus T1 like that, would that have changed anything?
It doesn't, because it doesn't matter which one's greater as long as you keep the T0 and T1 on the same side.
I think so. I think if you swap the order of the T0 and T1, as long as you were consistent about it, meaning you swapped all your T0s with all your T1s, it would cancel out. And I think we can actually see that algebraically, because if we factor a -1 out of our numerator is going to be -1 times the quantity f of T1 minus f of T0. And similarly, if we were to factor a -1 out of our denominator, we would have T1 -1 times T1 minus T0. And what's -1 divided by -1? Is 1. Swoosh, swoosh. -1s would actually cancel out in the top and bottom, and that expression would in fact be equal to this expression. Technically, if you did that, you would be doing something like taking the negative of the net distance traveled over the negative of time elapsed. Or maybe, if you've ever read, Once and Future King, Merlin's living his life moving backwards through time. So maybe if you were Merlin, you would do it this way because you're living backwards through time. Don't ask me what that actually means. And, but it would come out to the same answer either way. What would be different, though, would be if you said something like f of T1 minus f of T0 over T0 minus T1. That would be wrong because it would be the negative of what you would get from doing that or that. So if you swap the T0 and T1 in your numerator, you'd also need to swap it in the denominator. Yeah, good question. So, let's say you're at time t equals, I don't know, 4 hours. And you're driving down the road, and suddenly a cop pulls you over and says, sir or ma'am, do you know how fast you were going? How could we find what the speed of the car was, or the velocity of the car at time t equals 4 hours? So in other words, if I were to ask, what's the average velocity from t equals 4 to t equals 4 hours, what would you end up getting in this case if we plugged in, say, 4 for t0 and t1? What's that?
0.
Yeah, we'd be getting f of 4 minus f of 4 over 4 minus 4, using our general formula we just found, which would give us a 0 in our numerator and a 0 in our denominator. And what's 0 divided by 0?
Whatever you want.
Whatever you want. Believe it or not, that is, I like that answer, whatever you want. Because technically, if I were to say, what's 6 divided by 3, you would say 2, because 3 goes into 6 2 times. In other words, 2 is what you would have to multiply 3 by to get 6. If I were to ask you, what would you have to multiply 0 by in order to get 0? Technically, the answer is, well, if you multiply anything by 0, you get 0. So 0 for 0 could sort of be anything you want. So in our case, what this expression is going to come out to is sadness. Because if you told the cop, oh, well, I was traveling at a rate of 0 over 0, which is anything I want it to be, and I want it to be within the speed laws, cop's probably going to try and, like, at the very least give you a ticket, and at the most arrest you for being a smartass. So does that mean it doesn't make sense to look at how fast is the car going in 4 hours? You're driving a car. Your car hopefully has a speedometer. If not, you're probably in trouble. That's giving you a number saying, oh, at this point in time, you are going at 70 miles per hour, or 30 miles per hour, or 110 miles per hour. Because you're on the Autobahn or something. So one thing we're going to be looking at, and this will be in a few standards from now. I wanted to introduce the idea now so you'd start thinking about it, letting those wheels spin a little bit. This standard's focused on average velocity or average rate of change. Standard 4, I think 4 is going to be focusing around how can we determine instantaneous velocity or velocity at a single point in time. Because that is something we'd like to be able to compute, or at least to estimate using a table like this, but we're not going to be able to get it from our net distance formula. Because if we had the same point in time twice, no matter what that point is, it's always just going to come out to 0 over 0. If t0 and t1 are equal in this expression. Questions or comments? If you have a cop pull you over for speeding, try this out on them. Let me know how it works if they ever let you out of jail. Okay, so I wanted to introduce this concept of average velocity in terms of these sort of motion distance problems where I think it makes sense to look at them most strongly. But we can also compute what's called the average rate of change of an arbitrary function, where our function f of x doesn't necessarily have to represent anything specific. So in general, we can say given any function f of x, the average rate of change in And now I'm going to be moving on to page 4 in the packet of f from one value of x, x naught, to another value of x, x1 is going to be given by the expression f of x1 minus f of x naught over x1 minus x naught. So in other words, if you have two different points in time, you want to find what's the average rate of change of your function between those 2 points in time. You can use essentially what's the same formula as what we had on the previous page, sort of change in f divided by change in x, or change in t in the case of our car problem. And that'll give you average rate of change of your function over that point, over that distance in time. Question, what's a function? And I say, given a function f of x, what does that mean? Or maybe, since I know some of you probably have ideas but are scared to answer this, what does that mean to you?
It's a series of points where each x value has one y value.
Ooh, it's a series of points where each x value gives you one y value. That's sort of an interesting graphical description. I like it.
It's like an operation or a series of operations done to a number to give you an output.
An operation or a series of operations that you do to a number to give you some sort of output. I would agree with that. In general, I would describe a function as being a way to take in inputs, which we call, oftentimes, at least in this class, we're going to call our x values, and produce outputs, which we oftentimes call our y values. But it's basically, yeah, sort of like you could think of a function as being like a machine, a way of taking the inputs, a single input, and mapping it to a single output. So in our previous example, f of 3 was 150 because we are taking in one, as a way of taking in 1 unit, which is an hour, or a time period, in this case hour number 3, and it spits out 150 miles as a way of computing distance traveled at that point, or distance from home, not distance traveled at that point. So our average rate of change of our function f of x is going to be f of x1 minus f of x naught over x1 minus x naught. By the way, if you all keep taking math courses, you'll eventually see math courses where functions don't necessarily have to have anything to do with numbers. Where I could have a function, for instance, that takes in a student. I could have a function that takes in any one of you, and when it's done with you, it spits out your hometown. And that would also be another example of a function, and that it takes in inputs and has a way of saying for each input, it's going to give you a unique output. What's your hometown?
Phoenix, Arizona.
Sorry, what's your name?
Aiden.
Aiden. So for instance, if we were to take f of Aiden, you would get Phoenix. Hope you don't mind me plugging you into my function. And so while in this class, 99.9% of the time our functions are going to be dealing with numbers, something that takes in a number and spits out another number, I would argue that there's no reason necessarily why that has to be the case. A function really only has to be something that takes in whatever your inputs are, whether they be numbers or students or emotions. I could make a function, for instance, that says g of, that takes in me as an input and spits out my emotion right now. And that could be considered to be a sort of function as well. All right, enough silliness. We have this serious business in here. So let's look at the function f of x equals x squared from 1 to 4. average rate of change. If you ever see me write ROC on the board, I'm not like misspelling ROTC or anything like that. That's just shorthand for rate of change. What would the average rate of change of the function f of x equals x squared be from x equals 1 to x equals 4? What would we have to do if we wanted to compute that?
Take our equation, go up top, and kind of plug and chug.
Do some plugging and chugging?
Yeah.
Yeah, we could use x equals 1 as sort of our x naught, and x equals 4 as our x1. Or yes, we could do it in reverse as well, and it would give us the same answer in the end. And we would get f of 4 minus f of 1 divided by 4 minus 1. What's f of 4 going to be?
4 squared.
Yeah, it's going to be 4 squared, not 4 squared. It's not a game, although I do enjoy playing a good game of 4 squared. But if we plug 4 into our function, we're just going to get 4 quantities squared. And similar with 1. Where 4 squared is going to be 4 times 4 is 16, minus 1 squared is 1 times 1 is 1. Divided by 4 minus 1, I think that's going to give us 15 over 3, which is going to be an average rate of change of 5. Watts. Miles per hour, feet per second. Light years per attosecond. Units. A general catch-all answer that you hope answers the question. And truth be told, I think we're just going to leave our answer as 5 this time, because since our function wasn't given to us in some sort of physical representation where, oh, x is being measured in hours and f of x is being measured in miles. If you're just given like an arbitrary function like this, we can compute a number as our answer, but that number isn't necessarily going to tell us, we're not going to be able to necessarily put units on that number unless we were to make this into a word problem somehow by applying it to a real world situation. So if we don't have units on our number 5, what does 5 mean? We have a number 5 that somehow computes to something we called average rate of change.
That the average slope between 1 and 4 would be 5.
Slope? Slope of what?
The function.
Slope of a function. You mean of our parabola, y equals x squared? Gadzooks. Let's graph this function, see what we can make of this. Alright, y equals x squared. My intuition tells me it's going to look something like this. This graph may not be drawn to scale. Where if we look at point 1, there's our x naught. Our x1 is going to be over here at 4. Where, let's see, if we want the y-coordinate of this point right here, the y-coordinate is going to be 1, because if f of x is x squared, then f of 1 should be equal to 1, because 1 squared is 1. F of 4 should be at a y value of 16. And so you're telling me that this graph has a slope of 5. What does that mean in the context of looking at this graph? A slope of 5 from 1 to 4.
If you drew a straight line between 2 points, the slope of that line would be 5.
Ooh! Between this point and that point?
Yeah.
So let's do that. So if we draw a straight line, Look at that. Masterfully drawn. You're going to say that this line right here has a slope of m equals 5? Indeed. Now, this. I don't know how you improve on perfection, but I just did it. This line should have an overall slope that comes out equal to 5 here. Does anybody know what we call this line?
Secant line?
Yeah, we're going to call this line as this line has a special name. It's going to be called the secant line to f of x from x equals 1 to x equals 4 in this case. So oftentimes when we talk about the slope of a function, that can mean a couple different things. Usually we're used to thinking of slope as being something linear. Like if I give you a y equals mx plus b, the formula for a line, you'd say, oh, m, that's the slope. In general, we can talk about things like finding the slope of a function between 2 points, like at x equals 1 and or x equals 4, and talk about, hey, the slope in this case is 5 because slope, which in this case would be considered to be change in y over change in x, or delta y over delta x if you're feeling like you're at Hillsdale and need to introduce some Greek into your class. Well, the change in y between these 2 points is going to be 16 minus 1. The change in x is going to be 4 minus 1, which is exactly the computation we did over here in order to help us get our answer of 5. And the slope of this line connecting the 2 points on our graph of our function, we can call the secant line to the function between those 2 points. Now, what's really going to be spicy is in a few standards from now, when I say find the slope of the function at a single point instead of between 2 points. But for that, we're going to have to wait a week. Questions, comments, concerns about this example? Yes?
So can you explain why you use 16 minus 1 or 4 minus 1 for changing y and changing x?
Sure. So if we're looking at this, if we're looking at these 2 different points in space, I would argue that those 2 points are going to define a line. In fact, if you're Euclid, that's the first thing you assume about how points and lines should behave, is that between any 2 points there exists a unique line. Even if you forget to include the word unique because you're making mistakes. And yes, even Euclid can make mistakes. If you want to look at, in general, the way we compute what's the slope of the line is you look at the change in the y-coordinates between the 2 points on your line, divided by the change in your x-coordinates between your 2 points. For the change in y-coordinates, well, we can compute the y-coordinate of this point at x equals 4 by just plugging in 4 into the function, since the function is giving us the y value corresponding to whatever x value you plug in. So the change in y would be f of 4, so get this y value of 16 up here, minus this y value, which is f of 1, or 1. And so the change between these 2 y values is going to be our delta y, which gives us our 15. And similarly, if we divide by the change in x, well, the change in x from x equals 1 to x equals 4 is going to give us delta x equals just 3. And so if we use our usual means of computing slope by taking change in y divided by change in x, we would get 15 divided by 3 equals 5. Does that make sense? By the way, I'm glad when you all ask me questions like that. Even if it's something that maybe you think should be obvious but isn't to you. If it's not obvious to you, it's not going to be obvious to most of the class. So please stop me and ask those sorts of questions. We've got 5 minutes. Let's do another example. Man, almost gonna finish this. Let's find average rate of change of the function g of t equals 2 to the t from t equals -1, t equals 2. So in other words, if we look at our function, g of t equals 2 to the t, which is exponential function, so it's going to go woo. By the way, I have a huge rant to give you on exponential functions, but I'll save it for the standard where we talk specifically about those. If you want to compute the slope of the secant line to this function, by the way, if you like weird sound effects, I think we'll get along nicely. How would we find the slope of that secant line?
Why is it 1 and not -1?
Good question. Because I misread my own example. I knew that line was too good to be true. Alright, there's 2, here's -1. Instead of 1. Slope of that line. How would we compute that? I've heard enough from you.
Or you take the 2 points like for, because t is x, then you plug those into the equation g of t, find the y, and then use the formula you get change in y with change in x.
Yeah, I like it. By the way, I was joking just now, just in case that wasn't clear. I like to try and balance out responses to get more students in the class a chance to respond to questions. So if I purposely don't call on you, that's likely why, because I want to give other students a chance. But yeah, that's exactly it. We can sort of use our change in y formula, which is g of 2 minus g of -1, over our change in x, 2 minus -1, which is 2 squared minus 2 to the -1 over 2 plus 1, because you subtract a negative, becomes a positive. 2 squared is going to be 2 times 2 is 4. What's 2 to the negative first power going to be? 0.5. 0.5. I twitch at your decimals. Even if it does end up being a little bit more useful. But yeah, when you take a number to the -1 power, that just means you take its reciprocal. You put that number in the denominator instead of the numerator, which is going to be, what's 4? 4 is 8 halves, so you'll get 7 halves divided by 3, which I think is going to give us a slope of 7/6. So a little bit greater than 1. So in this case, m equals 1/6 is the slope of our secant line. And with that, I'm going to call it for today. Have a good weekend, everybody. Enjoy your first week of class. So when we come back on Monday, we're actually almost done with Standard 1 already, believe it or not. We'll finish off Standard 1, start talking about Standard 2. And on Wednesday, then, will be our first quiz, our Standard 1 quiz. And I'll talk again a little bit more about that quiz in Monday's class. In the meantime, hope you have a good weekend, and I will see you all on Monday. Thank you.